right, so I'm going to give you a very short introduction about Raven. So we are a young startup, or a startup to be, because we are not incorporated yet. And we are building lasers, ultra-fast laser that emits in the short infrared. I don't know how deep I should go through the tech, etc. So I make something very general. Sorry if it's obvious for everyone. So first of all, here you see the light spectrum. You know that for each different wavelength, you have a particular application. For X-ray, you can do imaging of your body. UV are widely used for silicon wafer, for processing silicon wafer. The visible is used for cutting million things. And the radio waves can also be generated via laser and are widely used for communication. But you can see that in the middle of the spectrum, there is a gap. There is no laser source here. Nevertheless, it's an interesting section of the spectrum. There is a lot of materials that can be processed here. And this is where Raven appears. So Raven can be a Swiss knife for material processing, especially for semiconductor or narrowband semiconductor, like silicon, for example. For organic material, you can think about kidney stone, for example, and also for plastic, especially transparent plastic. Some of them have an absorption that is interesting at 2 micron, and you can, of course, think about modifying structure, dividing, so cutting, but also inspecting. So what are we proposing? So just to be all on the same page, we are laser manufacturer. In a nutshell, for those who are not familiar at all with laser, a laser is just a bunch of optics, lens, and crystal put all together. And the particularity of our laser is that it emits at around 2 micron. And we have a somehow a modular system where we have Raven XS. It's a laser pump, so it's continuous. This is the basic unit, but you can already do some interesting processing with that. This Raven XS is already existing, and it's inside the black box that you see on the picture on the side. Just to give you some dimension, the aluminum box on the top is an A4 sheet. So inside this aluminum box, you have Raven S, which is an ultra-fast oscillator. So we have femtosecond pulses and nanojoule level, which is already enough to do some spectroscopy, for example. And Raven L, you see that it's in another color in the slide because it's not existing as a product yet. But this is the amplified version of our product range. And with that, you can really cover a wide range of application. So what is new in our laser? What makes them special? So maybe two main things. The way we are bonding and assembling the optical component inside the laser, and the new crystal that we are using. So the crystal is really the heart of the laser, and we pick it so that it emits at 2 micron, and give us also some nice features. So how does these two main game changer translate into features? It translates into a pulse-to-pulse steadiness. So I try to give some general wording for that. So it means that each pulse arrives at a very precise time and with the same amplitude each time. It's scalable in power. So you can reach millijoule level with this, with our technology, and we emit in this 2.1 micrometer wavelength. So which type of things we can do? So a variety of application, as I mentioned at the beginning. Welding transparent plastic. If you're not familiar with this processing, currently you need to have an absorber in between the two plastic you want to weld. With our laser, you can avoid these steps. You can directly weld the two plastic, and it makes the procedure simpler. You can do gas sensing. For example, there is 3 greenhouse gas, CO2, N2, and CH4 that can be detected in this wavelength. And you can also process a lot of some semiconductor, very important one, silicon or germanium, for example. And especially you can bond and debond some thin metal layer from wafers. And this is of interest when you know that there is always some glue left over on the wafer, so you ensure a better conformity. Those are examples, and you might think like, okay, Celia, you're diverging, you can do too much things. How are you going to build a business model out of it? Very simple. We just sell this laser to plant integrators, and they discuss them with the potential customers afterwards. So with that, we are part of the ultrafast and fiber laser source. Maybe this is not that much of interest for this crowd. I will move on. Competitors, it's interesting to keep in mind that currently, as I mentioned, there is no 2-micron high energy source. You need to choose. Either you want a low system, stable, and you choose fiber laser, it's fine, but you don't have a lot of energy, it's not scalable in power. Or you choose the big beast, the wavelength converter. So for those who are a bit familiar, it's OPCPA, but then it's millions of boxes, you need to tweak all this. It's great for scientists, but for industrial use, it's not the best. So we combine both worlds. And with Raven, you can have a simple and high energy system to process materials. And maybe for today, this is maybe one of the most important side, I would say. Our roadmap. So we, as I mentioned, are a very young startup. We got Exist Fortune Transfer, which is a national grant in January, which allows us to build Raven XS and S and already deliver them to our first pilot users. But we have further steps to enter the market, especially for Raven L. We think there is a lot to try out and to showcase. And we are really, if you have a particular material, I'm thinking about plastics and silicone mostly, that you would like to try out something new, that you would like to investigate with our laser, we are happy to think about it with you. And and to discuss like what can be done with this laser. So we are a team of 4. I think it's a good mix of nerdy scientists and business skilled people. So if you have any question about the business and finance, Millon is around. Otherwise, we are 3 scientists. Yisheng and Misha have 10 years of experience in building high power laser and 2-micron laser, and I've been not building laser, but using them for various applications. So I think we have a good team to think about your problem and potential application where we could collaborate or investigate something. I am already done. I know it was short, but I thought it was more interesting to get questions and exchange than having a very heavy talk about 2-micron laser.